Go.
Hello. Hello.
Hello, hello. Hello, remember what we have talked about yesterday?
Power of 3.
Okay, so today, similar, we will talk
Power
about
of 5.
2.
I said about 2.
Yeah, power of 2. So,
Two.
Imagine, can
Why?
you apply this power of 3 algorithm in the power of 2?
You just.
Can we?
I guess, yeah.
Yes. Okay, so let's, it's a good exercise. We can do this review, okay? Yeah, and then I introduce one more algorithm specific to the power of 2. So, are you okay? Alright?
Yeah.
So, can you tell me which algorithm you remember to check if the power of 2?
Oh, just keep dividing by 2.
2.
Two.
Okay, so
Yeah.
you tell me what to write, okay? Power 2, okay? And if n smaller than or equals 0,
What?
well,
1 minute.
yeah, if n smaller or equals 0, return what?
Return and
If-
no.
True or false? Small.
False. No.
False.
Yeah. I mean.
Okay, if n equals 1,
Return true.
yeah, because 2
Yeah.
because 2 to the power of 0 equals
That
1, yeah?
went up.
Yeah? Okay? Okay, now look. Y, n can be divided by 2 and divide equal 2, right? Yes? Yes? Return what? Return what?
Return n.
And what? When look a to the power of 2 divided by 2 divided by 2, then
Divided by.
it will be 2 and divided by 2 it will be 1. And if 9 can't be divided by 2 and can't reach this 1. If 6 divided by 2 equals 3, 3 divided by 2 can't be equal, so it's 3. So if it's power of 2, so n will be divided until we get 1. What?
1.
1, yes, well done. It's the same. Look, yesterday power of 3, we just changed this to 3. Yeah? Do you remember? Yeah?
Yeah.
It's the same. Okay, so look, n is an integer. We can replace this. N if n is an integer, n divided by 2 equals 0. It's the same as in the binary. Yeah? In the binary, if it's an even number, so the last digit of the binary is 0. So it will be n. Yeah, this is n. How do we write n? N 1 equals 0. It's the same thing. And then n divided by 2 in binary, right? Look, this is what in binary. This is what number in binary? 6. Yeah. This is what in binary. No. This is 4 in the binary. Yeah, because 1 to the power of 2 is this is 4, right?
1.
And this is what? This is what in binary. 1 times 2 power 1, that's 2, right? Yeah? And this is what in binary?
1.
So do you get it? If you're moving 1 to the right, then you'll be divided by 2, right? If you put a 0 at the end,
Times 2.
times 2. Okay, so this thing is you can do it like this. And shift equals 1. Look, yeah? 2 greater sign means that I want to shift 1 position to the right, yeah? And how about this? n 1 equals smaller equals 1. What does it mean? I want to shift to the left, yeah? Times 2, yeah? It's the same. What's the complexity?
N to the power 2. Log base. No, log 3 base.
No, there's no 3, 2.
2 I mean.
Log 2n, yeah?
Yes.
Yeah, because you're divided by...
Papa!
Okay.
I said.
Okay, let's divide it by... We can multiply, right? Look, yeah? X equals 1, yeah? You tell me. Y, x smaller than n, right? Yes? What should I write here?
Oh,
X what?
X.
X what? I want to times x equals 2, yeah? X equals x times 2, yeah? Or you can do this. Shift equals 1. That means times 2, right? Return what? Return here what?
2.
No, I times 2.
Pretend n equals 1.
X.
X
Look,
equals
E1, 2, 4, A 16 until you, for example, if I give you 33 and then 32.
It can't be 36.
Yeah, so what's here? Remember, it's the same as yesterday. Yesterday is X times.
False?
Not false, come on, you're not remembering it. I give a number, I times it 2 until it's bigger or equal to n. When it's equal,
It's true.
when it's bigger,
It's false.
okay, so what should I write here?
X equal
And then equal what?
1? No. N.
N, come on. This thing, look, double equal is the same. This thing is the same as if,
Double equal.
right? Eric, this is the same as, Eric, this is the same as if x equal n column, return what? Return what?
Return true.
Else what? Return what?
False.
Yeah? This is the same thing, yeah? This is the same thing, you see? Yes?
Yeah.
Okay, so what's the term complexity?
Log 2 n.
Yeah, it's the same thing. Okay, we can do it recursively as well. Look,
Recursively.
n equals 1, return what? Return what?
True.
Okay. Then return, it has to be divided by 2, yeah? N divided by, it should be an even number, yeah? Even number. N,
Looks like an.
n what? N power 2, n what? Divided by what? 2, right?
Yep.
Yeah. Yesterday it's the same.
Divided by
Yesterday-
3.
Yeah, and then you change this to n modulo 3 equals 0, yeah? Yesterday, okay? So this is the same, okay? And how about,
And you change power 3.
look, if I do this, basically we want to find if there's integer 2 to the power of x equals n, right? Yeah?
Yeah.
Okay, so x is log 2 n, right? Yes?
Yeah.
Okay, so let's do this. X equals log 2 n, but this could be an integer or not could be an integer, yeah? So we want to check if x is integer. So how can we do this? Return
2, 3.
integer, we convert it to integer. If it's equal to CR, what does CR mean?
See.
So look, integer is the floor, so like 2.5 int, yeah? Is 2, right? Int 2.5 is 2. Okay? Okay, actually this is this way. And int and CR, what's ceiling? CR 2.5 is 3. So it's
I know.
yeah?
Seal.
It's ceiling, yeah?
Yeah.
And integer is like a floor. So look at them 2.5. Ceiling is 3 and floor will be 2, right?
Yeah.
Oh, okay. Oh, how about this?
Fine.
Int 1.9. Int 1.9 equals what?
1.
And CR 1.9.
2.
Yes, well done. So what does it mean here? If it's the integer part and equals ceiling part, okay? So look, int 2 is 2, okay? CR 2 is also 2, okay? Got it? Yeah, because if it's a whole integer, it's the same, yeah? Yeah, okay. So if it is an integer, then we find this number, okay? What's the complexity? If we think this is O1, so what's the complexity?
What?
If this function is O1 constant, I assume it's very, very fast. It's
1.
yeah, O1 constant. Look, so this is basically is the fastest. Yes?
Yeah.
Yeah, because I just do the calculation, yeah? And how about if I can do this? If this is an integer, and I convert it to integer part. Yeah, integer. Yeah? And then I can do this. Return 2,
And 2.5.
2 times x equals
Up there
n.
is 3. And
Yeah.
up there, down there is 2.
This is I compute the log to n, and then I return the integer part, and I reverse check. I check 2 to the power of x if it equals n, yeah? Yes?
Yeah.
What's the time complexity? If it,
Log.
yeah, because this takes all log to n, yeah? This is the same thing as power function, yeah? Power 2x, right? This takes all log n. Remember, we talked about this before, yeah? To times, if you times this x times, then it's on, right? N times, yeah? But we can actually depend on, look, alright? 2 to the power of 6 equals what? 2 to the power of 3 times 2, right? Yeah?
Yeah. Square.
So look at you, every time you can do this faster, you just need 2 times instead of 6 times, right?
Yeah.
Yes? Got it?
Yeah.
Yeah, okay. So, okay. Binary search.
I am 2.5.
Remember, binary search is
Up
the
there
same.
is 3, and down there is 2.
Yeah, n smaller equals 0, return false, yeah? This is the same. Okay, you tell me, L, R, 0, N, okay? While L smaller equals R, right? Mid, what's mid?
Middle.
Mid, what does it meter equal?
Left add right divided by 2.
Yes, okay, and then I have a current value. Current value is 2 times mid, yeah? 2 to the power of mid. You can write it as this way, power to mid is the same. Okay? If current equals n, what should we return?
If carry equals.
We find the mid value and then we times it 2 to the power of mid. If it's 2 to the power of mid, yeah, return true, yeah, we're done. And if current is bigger than n, so look, this is L, this is R, and we find the meter. If this value is, if this to the power mid is bigger than the n, so where is it? Where is it? Is it in this house or this house?
If it's what?
If this middle value to the power mid bigger than n, so what's the value? Okay, so what should I write here?
Right equals mid minus 1.
Okay, we're done. And then else,
What?
else,
Left equals mid add 1.
and then here return what? Return what? Ryan, return what?
Return mid.
No, this I return true. Return what?
False.
False, yes, we're done. What's the time complexity? This is the same as yesterday, except this one. Yesterday, this is 3 to the power of meter, yeah? Yeah? The only difference between the power of 3 and power of 2, the binary search, is this one. Yeah?
And that one.
Yeah, that is functional. Yeah, remember yesterday, this is 3, yeah? Okay? So, what's the complexity?
Oh, yeah.
Divide, yeah. What's the complexity? Log n what? Is it true, log n?
To the power of 2.
This is log n, and how
Square.
about- yeah, square. You need to square it. It's actually log n times log n, because this is log n, and the binary search is log n. Okay, so it's log n. Okay, so for now we're just reviewing the power of 3. We can use the power of 3 equivalent to the power of 2 to change this 3 to 2, right? Mostly. And today we talk about something very good, very specific for the binary, for the 2. You know the 2, yeah? Computer loves the number 2, right?
Why?
Because the computer is based on the binary, yeah? But
The
computer
number 2.
understands 2 numbers. What are the 2 numbers computer understand?
1 and 2.
No.
No, 1 and 0.
0 and 1, yes. Because 0, computer can simulate as power off. 1 can be simulated as power on, right?
Yeah.
Yeah? High voltage, low voltage. The computers are loving these numbers. It's simple for computers, yes? So the binary, we talk about the binary, yeah? Yeah? 2 to the power of 0. Eric, you tell me what 2 to the
Equals
power
1.
equals 1. In binary, okay, I have a binary here, okay? Binary. And then you tell me what you found, yeah? Binary is 1, okay? 2 to the power of 1 equals 2, right? In binary is what? 1, 0, yes? Yes? Am I right?
Yeah.
2 to the power of 2 is 4. In binary is 1, 0, 0. Yes?
Yeah.
Yeah? 2 to the power of 1, 2. Yeah? 2 to the power of 1. Yeah? 2 to the power of 3 equals 8. In binary is what? 1, 0, 0, 0. Yes?
Yeah.
2 to the power of 4 equals what? 16.
1,
1,
0,
0, 0, 0,
0,
4, 0. So do you need me to keep writing? 1, 2, 3, 4, 5. Okay? So in binary, if it's power of 2, what does it?
It
It means that we only have one, and followed by lots of zeros.
Yeah.
Yeah, do you get it? This is binary, yeah?
Yeah.
Okay?
Yeah.
So how can we do this? How can we find the binary? Remember, we use this n, yeah? N logic. This symbol, yeah? Yes? N logic, yeah? Yeah? This is n. If you want to n the binaries, you use this one. And then there's
It
an
looks
O.
a bit weird.
Okay, so we just talk about this n, yeah? You know this symbol in the keyboard, here.
Oh yeah.
Yeah, this one, 7. Yeah, 7. You see? It's on the 7th. Yeah, this is n. Okay, so what does it mean? In
Looks
binary.
like two hooks.
Yeah. What does it mean?
Something like that's what it's like.
Okay, so wait up, look. So this n, yeah, the numbers, look, in binary, okay, so look, if it's 4 and 3
Exactly.
in Python, what's the value of 4 and 3? So computer will change this to binary, which is 0, 1, 1, 0, 0, yeah? And 3 is what?
1, 0, 1.
0, 1, 1, 0, 1, 1, yeah? Because 1 plus 2 is 3, yeah? That's 4, yeah? Yes?
Yeah.
So this n, what does it mean? Remember, 2 and 2 is 2. 2 and 4 is false. False and 2 is false. False and false is 2, yeah? It has to be both 1 in order to 1. So this will be 0. This will be 0. This will be 0. Got it? Yes? Yes?
Yeah.
Do you get it? So 4. So look, 8. Yeah? 8 is the power of 2. 8 is this one, yeah? Yes? 1, 0, 0, 0. If I subtract,
Power of 2.
if I subtract 7, what's 7? 7 is,
Not power of 2.
I know 7 is what? 0, 1, 1, 1, right? Yes? So the n together will be 0. Okay? Another one, 16. 16, 1, 0, 0, 0, 0. Minus 1 is what? 0, 1, 1, 1, 1, yeah?
Yeah.
You n 0. So do you get it?
Yeah.
This one, minus 1. 0, 1, 1, 1, 1, 1. You n 0. Yeah? Because look, 0 and 1 is n is 0. Yeah? Do you get it? Because you only have 1, 1. Yeah? It's subtract 1. All the 0 become 1. Yeah?
Yeah.
And then this becomes 0. Yeah? So you n together will be 0. So what can we do? Look, define power 2. Look.
If it's a power of 2, then you minus 1, then you just
N.
add both of them, and
Return. First of all, it has to be bigger than 0. Yeah? Bigger than 0. Look. Every n bigger than 0. Yeah? And look, n, yeah, and yeah. What should I put here? N what? N what? What's this number? This is n. What's this number?
n minus 1.
Yeah, well done. And will be
Yeah.
equal what? Equal what?
Equal
what?
0.
0.
0.
This is the fastest. What's the time complexity?
I what?
Oh, 1, yes, constant.
Yes.
What's the space complexity? Oh, what? Do we need a extra space? Do we need extra space? No, there's no. We don't need any space.
1.
Oh, 1 constant. Okay. So which one is the fastest, the best? This one. Yes, of course. Look, this is magic. Yeah, binary magic. Because computer loves binary, and then based on the binary, we can just check if the integer is power of 2. Just using this. It's amazing. Yeah. It's quite amazing. Yeah.
Yeah.
Yeah, we've got lots of algorithm. This is the fastest because it's all 1. It doesn't matter if you n is a billion, a million, a trillion. It doesn't matter. Computer computes it instantly. Yeah,
Yeah.
fastest. Okay, so I raise it. Okay, so how about I write the problem and then you tell me. Okay, one by one. Okay, who want to do first?
What do we do? Yeah.
Check the power of 2, yeah? If n smaller equals 0, what's here? And then, okay, x equals 1, y, x smaller than n, x
That's
equals
false.
1, and then,
Return false.
okay, and here,
Return true. No.
Return. This is return false. Yes, you are right. And then here.
Return x. Return x equals n.
We're done. Yes. Good job. Okay. Good job.
Yeah!
Good job today. Good job today. Good job. Woo!